Hi, my name is Lance Aspiras, a BS Civil Engineering student in UPLB.
Hi, my name is Lawrence Caranay, a BS Civil Engineering student in UPLB.
Hi, my name is Don Joseph T. Sarmiento, a BS Civil Engineering student in UPLB.
Hi, my name is Jeron Anthony Artores, a BS Civil Engineering student in UPLB.
Hi, my name is Trevor Lagdan, a BS Civil Engineering student in UPLB.
My name is Hannah Villarina, a BS Civil Engineering student in UPLB.
Hi, my name is Jad Batangantang, a BS Civil Engineering student in UPLB.
Hi, my name is Patricia Marie Luyon, a BS Civil Engineering student in UPLB.
Hi, I am Alisa Lane Ceremonia Dayo, a BS Civil Engineering student in UPLB.
Hi, my name is Timothy Valenzuela, a BS Development Communication student in UPLB.
Hi, my name is Freedom Christine B. Hernandez, a BS Development Communication student in UPLB.
We are here to present
Calculus.
The world.
In order to understand how things change, provide a framework for modeling systems in which there is change, and a way to deduce the predictions of such models, we need calculus.
Calculus is the branch of mathematics that deals with the finding and properties of derivatives and integrals of functions by methods originally based on the summation of infinitesimal differences.
The two main types of calculus are differential calculus and integral calculus. Differential calculus is focused on the rates of change and slopes of curves, while the integral calculus is focused on accumulation of quantities and the areas under and between curves.
These two branches are connected by the fundamental theorem of calculus that explains how the concept of the derivative of a function is linked with the concept of the function's integral.
Truly, calculus is a complex yet exciting way to understand how things change in a system. Thus, its development was not as easy as it may seem.
Generally, the birth of calculus is attributed to two great men of the 17th century, Sir Isaac Newton and Gottfried Leibniz, who independently developed its foundations. In line with this, the development of calculus can be described along a timeline that undergoes three periods: anticipation, development, and regularization.
During the anticipation stage, mathematicians use techniques that involve infinite processes to find areas under curves or maximize certain quantities.
Development stage, Newton and Leibniz created the foundations of calculus and brought all of these techniques together and classified them whether derivative or integral.
Lastly, the regularization stage was the period where
Newton-Leibniz methods were found not always logically sound. Thus, it took mathematicians quite a long time to justify them and put calculus in a sound mathematical foundation.
development of calculus, both Newton and Leibniz use infinitesimals, quantities that are infinitely small and yet non-zero. Of course, such infinitesimals do not really exist, but Newton and Leibniz found it convenient to use these quantities in their computations and their derivations of results.
At present, that's spread in various disciplines and it can solve many problems that geometry and algebra alone cannot.
That is true! Calculus is deeply integrated in every branch of the physical sciences, such as physics and biology.
It can also be found at work in computer science, statistics, engineering, economics, business, and medicine.
One of the applications of calculus is finding the slope of a curve, whereas calculus gave us a generalized method of finding the slope of a curve and how it will tilt in any given time, which is very useful in any area of study.
Next is calculating the x-intercept, whereas calculus provided us with the knowledge about the intermediate value theorem that says that when we have 2 points connected by a continuous curve, then there will be at least one place where the curve crosses the line. Using Newton's method, an irrational root can be calculated to any degree of accuracy, something a calculator cannot measure if it wasn't for calculus.
Another is visualizing graphs, whereas calculus allowed us to graph any function or equation we like and find the maximum or minimum values without even graphing a point by the methods of calculus.
Lastly, calculating the average of a function, whereas in calculus, a function can be a representation of many things, such as a speedometer that calculates a car's average velocity and acceleration.
Moreover, calculus is used regularly in wide variety of careers. Universities, the military, government agencies, airlines, entertainment studios, software companies, and construction companies are only a few employers who seek individuals with a solid knowledge of calculus.
Even doctors and lawyers use calculus to help build the discipline necessary for solving complex problems, such as diagnosing patients or planning a prosecution.
credit card companies use calculus to set the minimum payments due on credit card statements at the exact time the statement is processed by considering multiple variables such as changing interest rates and a fluctuating available balance.
Biologists use differential calculus to determine the exact rate of growth in the bacterial culture when different variables such as temperature and food source are changed. This research can help increase the rate of growth of necessary bacteria or decrease the rate of growth for harmful and potentially threatening bacteria.
An electrical engineer uses integration to determine the exact length of power cable needed to connect two substations that are miles apart. Because the cable is hung from poles, it is constantly curving. Calculus allows a precise figure to be determined.
An architect will use integration to determine the amount of materials necessary to construct a curved dome over a new sports arena, as well as calculate the weight of that dome and determine the type of support structure required.
Spaceflight engineers frequently use calculus when planning lengthy missions. To launch an exploratory probe, they must consider the different orbiting velocities of the Earth and the planet the probe is targeted for, as well as other gravitational influences like the Sun and the Moon. Calculus allows each of those variables to be accurately taken into account.
Statisticians will use calculus to evaluate survey data to help develop business plans for different companies. Because a survey involves many different questions with a range of possible answers, calculus allows a more accurate prediction for appropriate action.
A physicist uses calculus to find the center of mass of a sports utility vehicle and design appropriate safety features that must adhere to federal specifications on different road surfaces and at different speeds.
An operations research analyst will use calculus when observing different processes at a manufacturing corporation. By considering the value of different variables, they can help a company improve operating efficiency, increase production, and raise profits.
A graphics artist uses calculus to determine how different three-dimensional models will behave when subjected to rapidly changing conditions. This can create a realistic environment for movies or video games.
With all of that being said, calculus is a very important area of study, not only in math but in all disciplines of learning. Its development by Newton and Leibniz from a vague geometric and algebraic idea to a study of how things changed as we know today is truly exceptional. It is one of the greatest inventions of modern science since it offered the fundamentals needed in our lives. And that, our dear
viewers,
is calculus.
is the world.
have you anymore. Yes, sir. Yes, sir.